Hello everyone. We have a question on the board here. We want to solve it. It is from NECO SSE 2024. Part 1 of it, the question number 8. The question is from electricity and the students in SS1 and SS3, we see similar question in their coursework. So to begin the question, we have to read it out and see how it is. A wire of length 4 meters has a resistance of 6 ohms. If its radius is 0.45 millimeter, we are required to calculate the conductivity of the wire, taking that pi is equal to 3.14. To begin this, we employ the formula that can help us solve this. The formula we have is P arrow equal to PL over A, where R is the resistance of the wire, P is the resistivity of the wire, L is the length of the wire, and A is the cross-sectional area of the wire. Now, we write out the parameters that we have in this question. R is giving us 6 ohms, then the length of the wire is 4.0 meter, and A is not given, but we can use the parameters we have in the question to solve it. We have radius, so we can employ the question formula pi r squared to find the cross-sectional area of the wire. Now looking for this, r is equal to 0.45 millimeter. So we convert it to meters since the length of the wire is already in meters. So if we convert it, it will be 0.45 divided by 1000, which is 0.45 times 10 raised to power minus 3 meter. Now putting everything together, we have known that pi is 3.14. So it will be 3.14 times 0.45 times 10 raised to power minus 3, and we're going to square it based on the question. All right. In solving this now, we first of all find the answer to this. We have 0.45 times 10 raised to power minus 3, then we square. 0.45 times 10 raised to power minus 3, we square it. We're going to have 2.025 times 10 raised to power minus 7. So we're going to multiply it by this to give us the answer. So A now is equal to 6.3585 times 10 raised to power minus 7, and we have meter squared. All right, we have obtained the value of A. So what we now look for is a value of P, which is not given. So in order to get it, we make P the subject of the formula. P now will be this times this all over this. That is it. So we substitute now. On substituting, R is giving us 6. Then A is this 6.3585 times 10 raised to power minus 7 divided by 4. I already have this value in my calculator here, so I multiply by 6. P now will give us 3.8151 times 10 raised to power minus 6. Then we divide by 4. When we divide it by 4, we're going to have that P is equal to 9.53775 times 10 raised to power minus 7. So the resistivity now is 9.54 approximately times 10 raised to power minus 7. This is in ohms meter. All right, we have gotten very close to the answer. What they asked us to calculate is the conductivity of the wire. So to calculate conductivity, we employ the formula that conductivity is equal to 1 over the resistivity. So that will give us 1 over 9.45 times 10 raised to the power minus 7. All right, now for us to find the conductivity now, we have to turn this value in standard form to this point. And so it will be 1 times 10 raised to the power 7 to help us in our calculation, divided by 9.45. All right. Now, if you multiply this times this, it will give you 10 million. Okay. So we now divide by this value. So we calculate 1 times 10 raised to power 7 divided by 9.45. Our value will be 1.048. Our value will be 1.048 218.029. Now, converting it in standard form, if we convert it into standard form, it will be 1.048 times 10 raised to power 6. So this will be in ohms inverse and then meter inverse. So this is how to solve this question. I will show you another method to solve this problem, but that will be in our next video. So tune it for our next video.